How can we get some data in real-life experiments? We have devices which can do all measurements for us, and even calculations. Now, in this situation, the track is not horizontal. Well, I have to put something to make it tilted. Our first intention would be choose the axis horizontally. That would have been the wrong choice, because in that case, we would have to add another axis to describe the location using two numbers. Why would we do that? We can make our life much simpler if we choose the axis parallel to track. Even if it's not exactly horizontal, still it gives much easier description. There is a special program called LoggerPro. If you're close enough, you can hear the clicking sound. This is ultrasonic pulses travel away, and then when they reach an object, they get reflected and travel back like echo. And computer can measure the location of this card every tiny fraction of a second. It can sketch a graph for us. What does this graph show? At the top, here you can see numbers on a horizontal axis. They show time. What we see, it actually travels faster and faster. We know that. We can actually select a certain region. Do a fit. This mathematical object, a graph, is described by a specific equation. X equals a t squared plus b times t plus c. What is x? X is instantaneous location. What is t? T is time. Equation like that, which relates position and time, has a name, a motion equation. So this setup gives you the motion equation immediately. You don't have to think about it. And these coefficients, A, B, and C, measured for you by this software. A equals 0.13. You can ignore errors. B equals negative 0.009, and C equals 0.26. What does it mean? It means now you can calculate the exact location of this card anytime. You just have to pick a number, plug in that equation, and calculate. If you know by calculation or actual reading, x1, t1, x2, t2, or sometimes it's more convenient using a table, maybe more accurate, t1, x1, t2, x2. You can calculate displacement, average velocity, and even average speed if you want to, because what is the displacement? Difference, final minus initial, could have been x2 minus x1. How much time passed? Delta t, time 2 minus time 1. So from this graph, you can extract all information related to one-dimensional motion of this card. Now we know basically everything about one-dimensional motion in general.